Previously on our journey through time, we've seen the universe born in a fiery Big Bang, stars lighting up the cosmos, galaxies forming, and our own solar system taking shape. We witnessed Earth come to life from a molten ball to a breathing planet, oceans teeming with the first microbial life. Then came the Cambrian explosion, when complex life began its march across Earth's timeline. Plants colonized land, fish evolved limbs and crawled onto solid ground, and giant reptiles ruled during the age of the dinosaurs. But their reign ended in a global catastrophe, an asteroid impact that wiped out 75% of life, including the mighty dinosaurs. Now a new chapter begins. 65 million years ago, the aftermath of catastrophe. The clock reset for life on Earth. The impact unleashed energy greater than 1 billion atomic bombs, triggering massive fires, tsunamis, and a shockwave that raced across the planet. But it was what followed that truly changed the course of evolution. The skies darkened as soot and debris filled the atmosphere, forming a thick, sun-blocking shroud. For months, perhaps even years, sunlight barely reached the Earth's surface. This event, often called the impact winter, caused global temperatures to plummet. Photosynthesis ground to a halt, collapsing plant life and, with it, the herbivores that depended on them. With herbivores gone, carnivores soon followed. The food chain disintegrated. Over 75% of all species went extinct. Among them were the dinosaurs, the dominant creatures of the Mesozoic era, the once mighty Tyrannosaurus rex, the soaring pteranodons, and the massive Triceratops, all vanished, unable to cope with the sudden and extreme environmental changes. But amidst this global catastrophe, not all life perished. In the underbrush and beneath the soil, in burrows and crevices, a new group of survivors emerged: mammals. Tiny, adaptable, and largely nocturnal, these creatures had always lived in the shadow of the dinosaurs. But now, with their giant competitors gone, mammals found themselves in a world of open opportunities. Their survival wasn't random. Mammals had key advantages that helped them weather the storm. Their small size meant they needed less food to survive. Many could burrow underground, shielding themselves from the cold and debris. They were also generalists, able to eat a wide range of food, from insects and seeds to carrion. While the massive reptiles around them fell, these scrappy survivors endured. Among the earliest of these was a creature known as Purgatorius. Though no larger than a modern mouse, Purgatorius holds a significant place in the story of life. It is believed to be one of the first proto-primates, the ancient ancestors of monkeys, apes, and eventually humans. Purgatorius likely lived in trees, eating fruits and insects, an early explorer of ecological niches that were now vacant. In this fragile post-apocalyptic world, mammals slowly diversified. Evolution, no longer dominated by the towering reptiles of the past, began experimenting with new forms. Within a few million years, some mammals grew larger. Others developed better senses, more complex brains, and stronger social structures. The aftermath of the mass extinction was, paradoxically, the dawn of a new age, the Cenozoic era, often called the Age of Mammals. From the ashes of destruction rose the roots of future giants: elephants, whales, primates, and ultimately, us. 60 to 50 million years ago, mammals diversify. The world was recovering. Climate warmed significantly. It was a period scientists refer to as a greenhouse world. There were no polar ice caps. Sea levels were higher than today. This was a period of evolutionary experimentation and innovation. Mammals began spreading into every available ecological niche. Some returned to the trees, others thrived on the ground, while a few even ventured into aquatic environments. With rich forests and abundant food sources, evolution had a blank canvas, and it painted with incredible creativity. In the canopy, small primate-like mammals began to evolve. These early tree dwellers, similar to modern lemurs, developed grasping hands and feet, better vision, and more complex brains. These traits helped them move through the forest, judge distances, and interact with others, laying the foundation for the primates that would eventually lead to monkeys, apes, and humans. On the forest floor, hoofed mammals began to emerge. These were the ancestors of today's deer, horses, and antelopes. Their limbs became longer and more specialized for running, helping them escape from predators in the open terrain. Meanwhile, predators themselves evolved. Early carnivorous mammals, creatures like Myaxes, the ancestor of modern dogs and cats, developed sharper teeth, keener senses, and greater agility. Underground, burrowing mammals thrived. Their ability to dig and hide made them versatile survivors. Some were omnivores, eating roots, insects, and small animals. Others specialized in specific diets, giving rise to rodents and insectivores. But one of the most important evolutionary leaps during this period was the rise of placental mammals. Unlike marsupials, which give birth to underdeveloped young that must continue developing in a pouch, placental mammals could nourish their offspring internally for a longer period through a placenta. This allowed their young to be born at a more advanced stage of development, stronger, more capable, and better equipped to survive in the outside world. This gave placental mammals a competitive edge, allowing them to spread across the continents and evolve into an extraordinary variety of forms. From this point forward, they would dominate the land, sea, and eventually even the skies. Some took to the oceans, evolving into the ancestors of modern whales and dolphins. Others adapted for flight, giving rise to bats. Still others grew massive and powerful, becoming the early forms of elephants, rhinoceroses, and other megafauna. And among them, small primates continued to evolve, each generation bringing them one step closer to the emergence of the human lineage. This was a time of rebirth, reinvention, and rapid change. The age of mammals was in full swing, and it was just getting started. 30 to 40 million years ago, the first giants. The age of mammals was now truly underway, and evolution was thinking big. During this time, between 50 and 40 million years ago, mammals began to expand not just in variety, but in size. With abundant food, a warm and stable climate, and few major predators, some mammals started to evolve into true giants. On land, one of the most impressive was the Uintatherium, a massive rhino-like herbivore that roamed the forests and floodplains of North America. Standing over 13 feet long and weighing more than 2 tons, it had thick legs, a bulky frame, and strange bony protrusions on its skull. Some researchers believe these knobs supported small horns or were used in headbutting rituals, similar to today's bighorn sheep. Despite its fearsome size, Uintatherium was a plant eater, grazing on the lush vegetation that thrived in the tropical climate. Meanwhile, far to the south, South America was isolated from the rest of the continents, creating an evolutionary island. In this biological laboratory, mammals evolved along unique paths. One such creature was the Australopithecus, a strange-looking herbivore with features that seemed like a mashup of different animals. A long body, short legs, tusk-like teeth, and possibly a short trunk like a tapir. These animals, and others like them, were part of South America's own separate evolutionary experiment, producing animals found nowhere else on Earth. But the revolution wasn't just happening on land. In the oceans, mammals were undergoing an extraordinary transformation. The descendants of land-dwelling, hoofed creatures were evolving into the world's first fully aquatic whales. Among the most impressive was Basilosaurus, a marine mammal that could grow over 50 feet long. Despite its name meaning king lizard, Basilosaurus was no reptile. Its elongated, serpentine body moved like a sea snake, and though it still had small, useless hind limbs, remnants of its land-dwelling ancestors, it was a powerful predator. It hunted large fish and other marine animals, ruling the warm seas of the Eocene. At the same time, the skies were no longer ruled solely by birds. Bats, one of the most successful flying mammals, had taken to the air. Their wings, formed from elongated fingers covered by a thin membrane, allowed for agile flight. Even more remarkable was their development of echolocation, a biological sonar that enabled them to hunt insects in complete darkness. With flight and advanced sensory adaptations, bats quickly spread across the globe, carving out a niche in the nighttime skies. This was a time of conquest. Mammals were no longer just survivors. They were pioneers. They had spread into every corner of the earth. On land, towering herbivores roamed ancient forests. In the sea, giant predators patrolled the waves. And in the air, winged mammals flitted through the dusk. From this point onward, mammals would continue to diversify, dominate, and shape the ecosystems of Earth. The giants had arrived, and the world would never be the same. 40 to 30 million years ago, primates advance. As the Earth continued to warm and stabilize, vast tropical forests blanketed large parts of Africa and Asia. In this rich and complex environment, a remarkable group of mammals began to flourish: the primates. These early primates had already developed some of the core features that define the group: grasping hands and feet, forward-facing eyes for accurate depth perception, and larger, more complex brains. Living in the trees of these dense forests demanded strong coordination, quick reflexes, and good judgment traits that would serve primates well over millions of years. Around this time, a major evolutionary split occurred in the primate family tree. One branch would give rise to the monkeys, both the New World monkeys of South America and the Old World monkeys of Africa and Asia. The other branch would become the apes, and eventually, us. It's in this second group, the apes, that our own story begins to take shape. These early apes were arboreal, spending most of their time in the trees. Their hands became even more dexterous, allowing them to grasp branches, peel fruit, and manipulate objects. Their brains continued to grow, supporting better memory, problem-solving skills, and more advanced social behaviors. Unlike earlier mammals, these primates didn't rely heavily on smell to understand the world. Instead, vision became their dominant sense. With eyes positioned at the front of their face, they could better judge distances, a vital skill for moving through the forest canopy and spotting both predators and prey. Socially, these primates were becoming increasingly complex. They began to form larger, more cooperative groups, where individuals interacted through grooming, vocalizations, and even early forms of nonverbal communication. Living in groups brought safety, but it also introduced new challenges, like competition, bonding, and maintaining social harmony. All of this demanded sharper thinking, more emotional sensitivity, and a growing capacity for learning from others. The seeds of human intelligence were being sown, not through tools or fire just yet, but through behavior, adaptation, and social connection. These early apes learned by watching. They remembered what worked and what didn't. They passed on knowledge through generations in subtle, nonverbal ways. Some scientists believe that these growing social complexities were one of the major drivers of brain evolution. In short, learning to get along and get ahead in a social group may have been just as important to intelligence as solving puzzles or finding food. By the end of this period, the stage was set. The line that would eventually lead to humans had formed. Our distant ancestors were still living in the trees, but they were evolving minds capable of more, of understanding, adapting, and connecting. It would take millions more years and countless environmental shifts, but the path was now clear. The story of primates was becoming the story of people. 30 to 20 million years ago, cooling Earth. The Earth was changing once again. After millions of years of warmth and dense tropical forests, the planet began to cool. The shift was driven by powerful forces beneath the surface. Tectonic plates collided, lifting vast mountain ranges like the Himalayas, which dramatically altered wind and weather patterns. At the same time, ocean currents were redirected, reshaping the global climate. The warm, stable Eocene world was coming to an end, and a new chapter was beginning. Antarctica, once covered in forests, started to freeze. For the first time in tens of millions of years, permanent ice sheets formed at the South Pole. As glaciers grew and temperatures dropped, sea levels fell. This climate transformation had a global impact, triggering a cascade of environmental changes. One of the most significant was the spread of grasslands. As forests thinned out and open plains expanded, mammals had to adapt or disappear. The rise of grasslands called for new survival strategies. Grasses, unlike leaves, are tough and abrasive, filled with silica that wears down teeth. In response, herbivores evolved complex, high-crowned teeth to handle the constant grinding. To survive in open terrain, they needed to move faster and farther. This led to the evolution of long, powerful legs built for speed and endurance. It was during this period that animals like horses, antelopes, and camels began to take on more familiar forms. Early horses, which once resembled small forest dwellers with multiple toes, now became larger, faster, and more specialized for running across open plains. And with prey came predators. To catch these fleet-footed grazers, carnivores had to become just as fast and even more cunning. Packs of early wolves, hyenas, and large cats emerged, refining their hunting techniques and developing sharp senses and agile bodies. The familiar predator-prey arms race had begun, shaping the landscape of life on land. Even in the midst of this terrestrial upheaval, primates continued to evolve. The forest canopy was no longer the only home for our ancestors. With less tree cover, some primate species began to spend more time on the ground. One of the most important genera from this time was proconsul, an early ape that still moved through the trees, but was equally at home on solid ground. Proconsul had a mix of monkey-like and ape-like features. It lacked a tail, had a more flexible spine, and showed signs of a larger brain. It represents a crucial step in the journey, from tree-dwelling primates toward the ground-dwelling apes that would eventually give rise to humans. In this age of cooling climates and changing ecosystems, evolution was picking up speed. New challenges forced mammals to adapt rapidly, and the world we know today began to take shape. The Earth was no longer just a warm, green paradise. It was becoming a place of diverse environments, of swift runners and clever hunters, of emerging apes and deepening intelligence, and the human story was inching closer. 20 to 10 million years ago, rise of the great apes. This was the golden age of apes, a time when they weren't rare or endangered, but widespread and thriving. During this period known as the Miocene epoch, dozens of ape species emerged and flourished across Africa, Asia, and even Europe. These apes came in all shapes and sizes. Some were small, agile tree swingers that zipped through the canopy with ease. Others were massive and ground-dwelling, like the incredible Gigantopithecus, a distant cousin of today's orangutans that could grow up to 10 feet, tall and weigh over 1,000 pounds. Imagine a creature like a gorilla, but supersized and roaming the ancient forests of Asia. This incredible diversity reflected a world teeming with opportunity, but also with growing challenges. Among the many ape species that lived during this time, one in particular stands out, Pierolapithecus. Discovered in modern-day Spain, Pierolapithecus lived around 13 million years ago and may have been a common ancestor of both modern great apes and humans. It had a unique mix of traits, strong, mobile shoulder blades and stiff lower backs for climbing trees, but also hints of more upright posture, suggesting it might have walked, occasionally on two legs when on the ground. This combination of arboreal and terrestrial abilities makes Pierolapithecus a critical link in our evolutionary story. It represents a turning point, where some apes began to explore life, not just in the trees but also on the forest floor. Meanwhile, the planet was once again shifting. The stable warmth of earlier millennia was giving way to a drier, more variable climate. Forests began to thin, especially in East Africa and parts of Asia. In their place, open woodlands and savannas started to spread. This environmental transformation pushed many species, especially the tree-dwelling apes, to adapt or decline. Some apes remained in the forests, evolving into modern species like orangutans and gibbons. Others began to venture into the open, learning to survive in a world with fewer trees, more predators, and bigger temperature swings. To adapt, apes had to become more versatile. Some developed stronger legs for walking on the ground. Others evolved more complex social structures, improved communication, and greater intelligence to help them navigate changing environments and group dynamics. It was a time of intense natural selection, where only the most adaptable survived. And in that crucible of environmental stress and opportunity, the path toward humans was beginning to narrow. Though we were still millions of years away from the first true hominins, the blueprint was being written, in bodies like Pierolapithecus, in behaviors like tool use and group living, and in the growing brains that made sense of a more complex, unpredictable world. The great apes were not just surviving, they were innovating, exploring, changing. And among them, the seeds of humanity were quietly taking root. 10 to 5 million years ago, the hominins emerge. The Earth continued to change, becoming drier, cooler, and more open. Dense forests gave way to expanding savannas and grasslands, especially across East Africa. And with this shifting landscape came one of the most profound moments in our evolutionary story, the rise of the hominins, our earliest human ancestors. Some apes began spending more time on the ground. Trees were no longer as reliable for shelter or food. On the open plains, survival demanded a different strategy. These apes began to stand more upright, moving on two legs instead of four. This adaptation, bipedalism, was revolutionary. The earliest known hominin, Sahelanthropus chidensis, appeared around 7 million years ago in what is now Chad. At first glance, Sahelanthropus looked like an ape, with a small brain roughly the size of a chimpanzee's, but its skull tells a different story. The position where the spine connects to the base of the skull suggests it held its head upright, evidence that it walked on two legs. Soon after, around 6 million years ago, we see Aurorantuganensis in Kenya. Though it still climbed trees, its leg bones indicate it spent a significant amount of time walking upright. Then, around 4.4 million years ago, came Ardipithecus ramidus, or Ardi. This species had a curious mix of traits. a grasping big toe for climbing, and a pelvis adapted for walking. Artie's world was a transitional one, forested but thinning, forcing adaptation to both ground and canopy. But why was walking on two legs so important? Bipedalism changed everything. It freed the hands to carry food, use tools, and care for young. It allowed early hominins to see over tall grasses, spot predators, and travel efficiently across long distances. Over time, this upright posture led to major anatomical changes: a reshaped pelvis, an S-shaped spine, and feet designed for balance and motion, not gripping branches. Free hands also meant more interaction with the environment. Early hominins could dig for roots, crack nuts, and potentially even use basic tools, long before tool-making became widespread. With these new abilities came increasing cooperation, group living, and the roots of social behavior that would define our species. It's important to note, these early hominins were not human, but they were no longer typical apes either. They represented something new, something in between. They walked on 2 feet, yet still climbed trees. They had small brains, but their behavior was beginning to shift. Evolution was slow, gradual, and full of trial and error. But the emergence of bipedalism marked the first true step toward humanity. This era was not about dominance. It was about adaptability, about changing with the planet and taking risks that would one day lead to the rise of Homo sapiens. From these humble beginnings, on 2 feet, in a world of predators and uncertainty, the story of us had begun. 5 to 2 million years ago, the tool makers. As the Earth continued to cool, a new chapter of human evolution was unfolding. Climate shifts brought dry seasons, fluctuating temperatures, and expanding grasslands across Africa. These challenges set the stage for a dramatic leap in the capabilities of our ancestors. This was the age of Australopithecus and the birth of tools. Australopithecus was not quite human, but not just ape either. These hominins were fully bipedal. They walked on 2 legs consistently, leaving behind the forest canopy and adapting to life on the open savanna. Their posture freed their hands, and with this came new possibilities. The most famous member of this group is Australopithecus afarensis, and among them, one skeleton stands out: Lucy, discovered in Ethiopia and dated to about 3.2 million years ago. Lucy was small, standing just over 1 meter tall. But her skeletal structure revealed something profound. She walked upright, had a pelvis suited for bipedal movement, and lived in a world not unlike our own African grasslands. Australopithecus may have used simple tools, stones or sticks, picked up and used instinctively. But the real technological breakthrough came with a new species, Homo habilis. Nicknamed the Handyman, Homo habilis appeared around 2.4 million years ago. These early humans had larger brains than their Australopithecine ancestors, and more importantly, they made tools. Not just any tools, but deliberately shaped stone tools, used for cutting meat, scraping hides, and cracking bones to access the nutritious marrow inside. This behavior was revolutionary. It marked a cognitive shift. These hominins weren't just reacting to their environment, they were actively modifying it to suit their needs. Toolmaking meant survival in a world that was becoming increasingly dangerous. Because while our ancestors were evolving, so was the animal kingdom around them. Massive herbivores like mammoths, woolly rhinoceroses, and giant ground sloths roamed the landscapes, and they were stalked by formidable predators: saber-toothed cats, giant hyenas, and terror birds in some regions. Life was harsh, competition was fierce, and only the most adaptable could thrive. This time also marks the beginning of the Pleistocene epoch, better known as the Ice Age. Though glaciers didn't yet dominate the Earth, the cooling climate triggered dramatic environmental shifts: drier conditions, seasonal extremes, and the spread of open habitats. These changes pushed early humans to cooperate, to share knowledge, and to innovate. Homo habilis didn't just survive, they paved the way. Their tools, social structures, and mental abilities marked the beginning of a new kind of life on Earth, one where intelligence, not strength, would become the ultimate survival strategy. From Australopithecus to Homo habilis, this was more than an evolutionary transition. It was a transformation in how hominins lived, thought, and interacted with the world. The age of toolmakers had begun, and with it, the long road to modern humanity. 2 million to 200,000 years ago, Homo erectus. With the arrival of Homo erectus, Human evolution took a bold leap forward. These early humans were unlike anything that had come before. They stood tall and upright, some reaching heights close to modern humans. Their bodies were athletically built, suited for endurance running and long-distance travel. But it wasn't just their bodies that set them apart. Their brains were larger and their minds more advanced. Homo erectus was the first true explorer of the human story. Around 1.9 million years ago, they began leaving Africa, spreading across continents. Fossils of Homo erectus have been found as far as Georgia, China, Indonesia, and Europe. This global migration was a milestone. Humans were no longer bound to one region. We had become a mobile, adaptable species. What made this possible? Fire. Homo erectus is believed to be the first hominin to control fire. This was a revolutionary achievement. Fire brought warmth in cold climates, protection from predators, and the ability to cook food, making it easier to digest and unlocking more calories. Cooked meat helped fuel the brain's rapid growth, feeding intelligence. Their tools also advanced. Instead of just sharp flakes, Homo erectus created hand axes, large, teardrop-shaped tools used for butchering meat, digging roots, and even woodworking. These weren't random stones. They were deliberately shaped, showing planning and skill. Socially, Homo erectus became more complex. They likely hunted in coordinated groups, using teamwork to bring down large animals. This required communication, possibly a proto-language made up of gestures, expressions, and a growing range of vocal sounds. They probably cared for their injured and elderly, showing a sense of empathy and community rarely seen in earlier species. They also began to alter their environments. Some archaeological evidence suggests that Homo erectus may have constructed simple shelters, an early sign of humans shaping the world around them to suit their needs. And all of this was happening against a backdrop of climate chaos. The Ice Age wasn't a single freeze, but a series of glacial advances and retreats. Environments changed constantly. Forests turned to deserts, plains to tundra, rivers appeared and vanished. But Homo erectus endured. They adapted to tropical jungles, grassy plains, and icy forests. They became true masters of survival. And while Homo erectus thrived across the globe, back in Africa, evolution was still at work. Deep in the shifting ecosystems of the African continent, a new lineage was forming. A species with an even larger brain, even greater adaptability, and the spark of something extraordinary. The foundation had been laid, the stage was set, and humanity's next great leap was just around the corner. 200,000 years ago, the arrival of Homo sapiens. Around 200,000 years ago, a remarkable new species emerged in Africa, Homo sapiens, the earliest form of modern humans. What made them different wasn't just their appearance, which was close to ours, but their minds, vast, complex, and capable of things never seen before in the animal kingdom. Homo sapiens possessed brains wired for language, imagination, and planning. They could think abstractly, communicate complex ideas, and envision the future. This cognitive leap allowed them to innovate in ways no other hominin could. But the world they entered was not empty. Other human species, like the Neanderthals in Europe and Western Asia, and the mysterious Denisovans in Asia, also walked the earth. For thousands of years, these groups coexisted, sometimes competing, sometimes exchanging knowledge, and sometimes even interbreeding. Modern genetic studies reveal that all non-African humans carry traces of Neanderthal and Denisovan DNA, proof of ancient encounters that shaped us. As Homo sapiens spread beyond Africa, they adapted to an incredible range of environments: arid deserts, icy tundras, dense forests, and vast grasslands. This adaptability was a testament to their resourcefulness and intelligence. But it was not just survival that defined them, it was culture. Homo sapiens were the first artists. Deep in caves around the world, they painted vivid images of animals, humans, and abstract symbols on walls that have survived tens of thousands of years. These paintings weren't just decoration. They were expressions of belief, storytelling, and identity. Jewelry made from bones, shells, and stones was crafted, suggesting a sense of self-awareness and social status. These adornments were more than ornaments. They were statements of belonging and culture. Perhaps most profoundly, Homo sapiens began to bury their dead. These early burials often included tools, ornaments, and even flowers, indications of spiritual thought and respect for life and death. This was the beginning of rituals, religion, and the complex social bonds that define humanity. Around 60,000 years ago, some groups of Homo sapiens began migrating out of Africa in waves, eventually populating the globe. This great migration led to the peopling of Asia, Europe, Australia, and finally the Americas. Through this expansion, Homo sapiens encountered other human species, sometimes outcompeting them, sometimes interbreeding, and sometimes blending. Over time, Homo sapiens became the dominant species on Earth, not just through strength or numbers, but through culture, communication, and cooperation. Our ancestors weren't just surviving, they were dreaming. They imagined worlds beyond their own, created myths and stories, developed tools and art, and formed communities that would grow into civilizations. This era was the dawn of what it means to be human, a journey of creativity, empathy, and endless curiosity. From these early steps, humanity's story continues, one of endless exploration, innovation, and the power of the mind to shape the world. The story of mammals is a story of resilience, of seizing the moment when disaster struck. From the ashes of the dinosaurs, mammals rose, not as rulers of brute strength, but as masters of adaptability, nurturing, and intelligence. But their greatest creation is still to come. One species will not just adapt to nature, but will seek to control it, shape it, and question its own place in the universe. Stay tuned for episode 7, where the dawn of civilization begins and humans reshape Earth in ways never seen before.